Welcome to part 11 of Algorand for Visual Studio. In this video, we will briefly explain inner transactions and how to use them in a C# smart contract. This is an app call transaction. An inner transaction is simply a transaction initiated from within a smart contract. It is called an inner transaction simply because it occurs inside the context of an app call transaction. When we make an app call transaction, we must always specify in advance any accounts, assets, applications, or anything else in storage the program will try to affect. It is a technical requirement of the Algorand platform. You can find out more about this topic, foreign arrays, on the Algorand developer portal. We see an example of this here, with an ABI method that takes one incoming payment, a split ratio, and two destination accounts, and also a reference to another smart contract, which we will talk more about in a later video. The method will be implemented to take an incoming payment and split the payment to each recipient, where the recipients must be passed in as arguments. It is not possible to specify random target accounts. They must be passed in. First, we add code to calculate the split per account. Now we declare and call an inner transaction to make the payments. Notice that the inner transaction calls must occur in a specially decorated local function. This is necessary to instruct the compiler to handle transaction sequences in a special way. Please see the Algorand for Visual Studio inner transactions section for more info. Because we are using decimal arithmetic, the amount of machine code instructions for this contract is quite high. We can increase the allowed budget by paying for extra budget by incurring the cost of another inner transaction. This technique is called opcode budget upping, or OPUP for short. Here we achieve this by making a contract-to-contract inner transaction call. There are two ways of submitting inner transactions. Individually, like this, or as a group, which is expressed by using a value tuple. There is, however, one limitation. In one inner transaction local function, you can only access the most recent transaction. For example, this is permitted. But this is not. When we update our proxy, we get a method that must be called like this. Before we call it, we need some prerequisites. First, the OPUP contract must be deployed and have an ID. We also need to fund the contract, because a contract account must have a minimum balance to initiate transactions. This is achieved with an account helper method as part of the tooling. Then we need to create the payment transaction to the contract that will be split. Note that destination address is the address of the application, calculated with a .NET SDK helper method. The app call to split payment has a number of parameters. The sender of the app call transaction, the total fee, in this case 4,000 microalgos for a total of 3 inner transactions and 1 outer, the payment transaction, the ID of the OPUP contract, user 1's address, user 2's address, and the percentage split to give to user 1 from the payment. When it is invoked, the payment will be first sent to the smart contract, which will then split it into inner payment transaction between certain recipients according to the given percentage. The result is a test result showing the amount paid to the second recipient. It is 78% of the payment amount, which was 40,000. It also shows that the smart contract executed successfully. With the .NET SDK, we could easily read the account balances and check the recipients got the funds. So in summary, inner transactions are transactions generated by smart contracts in the context of an application call. Algorand for Visual Studio allows you to make inner transactions by decorating local functions. Transactions can be submitted individually or as groups by expressing them as a value tuple. Each inner transaction local function can only assign a transaction to a variable once, due to platform limitations. Thank you for watching.